So this is a two-root question. Let's write that down there. And we're going to go from position 0 to position P. So I need to find the vector O to P in two different routes. So the first route I'm going to take is I'm going to be thinking about going from O to A and then O to P. And the second route that I'll be taking will be going from O to M and then M to P. So part of the clue for that in this question was this here, where it said M, P and N is a straight line. So I've actually just put that vector in there to make it clearer on the diagram that I'm going to be finding ultimately MP as being a fraction of M to N and so on. Okay, let's focus on the blue route first. So O to P is equal to O to A plus A to P. Now, I don't know what A to P is, but I know it's a fraction of A to B. So we'll use the letter K for that, for this. Okay, so K is A to B. So let's just find the vector A to B. So A to B is going to be equal to O to B minus O to A. I've been told that O to B is B and O to A is A. So I've got B minus A. So I'll substitute that back into the whole expression then. So I've now got A, linking to that there, plus K lots of B minus A. Now I'm just going to expand this out and collect like terms because I know it is a two-root question. So I have to go to this, the O to P in two different directions. So A plus KB minus KA, collect those A's together. So I've got 1 minus K of A plus KB. Okay, so let's just group that together and minimize it and put it to one side and then focus on the next route, the green route. Actually, I'm going to change colors and call it the black route. Okay, I think it's a bit easier to see that. So getting to O to P from the second direction, so that's going to be O to M plus M to P. Okay, well I know O to M, it tells me it's the midpoint of B. So that's going to be the vector half B. Plus MP is some fraction of M to N. So we'll use a different letter here. So we've got K for that other fraction. Let's use, I'm going to use T. So it's a fraction of M to N. Okay, now we need to find out what M to N is. So half B plus T lots of, so M to N is going to be the case of going to M to O plus O to A and then A to N. So I've already put the information on with about those two vectors there. So it's going to be a half B plus T lots of M to O, so that's going to be minus B over 2 plus O to A plus A to N, so that gives me 3A there. So I'm going to expand that out and collect the like terms again. So I've got half of B plus, well, it'll be a minus, won't it? Or minus T over 2B plus 3T of A. I'm collecting like terms. So 3T over A plus, I've got a half minus t over 2 lots of b there. Okay, so that's my second vector for O to P. So I'm just going to minimize that, put it to one side, like so. Now, we said here that these two roots must be equal to each other because the vectors O to P are equivalent. So I'm now going to set these to be equal to each other here. So I've got 1 minus k A plus kb, and that's equivalent to 3t A plus a half minus t over 2b. Okay, so I can now equate the vectors here, the coefficients. So I've got 1 minus k is equal to 3t. And then for the vector b, I've got a coefficient of k and equivalent to that. So k is equal to half minus t over 2. Okay, now I want to try and find the value of k, but I'm just wondering whether it might be easier to find the value of t first and then substitute in. So if I rearrange this equation here to make k is equal to 1 minus 3t, okay, and then substitute that into this equation here. So I've got 1 minus 3t is equal to half minus t over 2. I multiply both sides by 2, so I've got 2 minus 6t is equal to 1 minus t. So 1 is equal to 5t, so t is equal to a fifth. So I've got a fifth there. Let's just minimize this now, working with that. Now that I know t is equal to a fifth, I can now substitute it back into establishing my value of k here. So k is equal to 1 minus 3. So k is 1 minus 3 fifths. So k must be equal to 2 fifths.